All right, next we're going to be talking about ionic compounds and how to name and write them. First, let's tackle how to write them. You always write the cation first, the one with the positive charge. Then, to use the crisscross method, you write the charges above each of the atoms. If the charges add up to 0, you're done. They just have combined in a 1-to-1 ratio. If they don't add up to 0, then you have to play the crisscross game. Just crisscross the numbers, not the charges. You'll see what I mean in a second. If you need more than one polyatomic ion, use parentheses. We don't see that in any of the examples today because that's coming up in the next lesson. Note, sometimes elements can have more than one possible charge, the transition metals, and so you'll see that the name tells you, based on the Roman numeral, what the charge of that cation is. And just to refresh your brain on Roman numerals, here's a Roman numeral 4. Okay, so for example, FeCl3. Chlorine always has a -1 charge. So if each of these chlorines is accepting an electron, and there's 3 of them, how many electrons must this iron be giving up? The answer is it must be giving up 3. So it would have a +3 charge, and you would name it iron 3 chloride. Let's look at another example. What if you've got 2 coppers and 1 oxygen? Oxygen always wants to gain 2. So how many electrons is each of these giving to the oxygen if there's 2 of them? Well, each copper must be giving 1 electron up. So the name of this compound would be copper 1 oxide, because copper would lose 1 electron to form a +1 charge. Finally, here's kind of a tricky one. Each of these sulfurs wants to gain 2. So total here, we're looking to gain 4 electrons. So if 1 manganese satisfies those 2 sulfurs, how many electrons must manganese be giving up? The answer is it wants to give up 4 electrons and form a +4 charge. Let's look at some examples of how to write the ionic compounds. So write the charges above each, crisscross, and you end up with Al2O3. And if we think about this, each of these aluminums is giving up 3 electrons. So total, this is giving up 6 electrons. Each oxygen can accept 2 or gain 2. So you need 3 oxygens to accept all 6 of those, because each oxygen can only accept 2. Another example, magnesium nitride. Crisscross the numbers, and the formula would be Mg3N2. That's the best way to write a neutral ionic compound. Here we go. Iron, which is a transition metal, it has to tell you what the Roman numeral is here, the charge. So it's a +2 because it's Roman numeral 2. Chlorine's always a -1, so you don't need to crisscross the 1. It's just FeCl2. Last example, aluminum bromide. Crisscross that 1 and that 3, you get AlBr3. Alright, how about naming them? You always name the cation first. You only use Roman numerals in the name when you're dealing with transition metals. There are some exceptions. Sometimes you'll see that lead and tin, which are not transition metals, will have Roman numerals. And on the other hand, you'll see that some transition metals, silver and zinc, won't have them. That's because scientists have this memorized, that they know that silver is always a +1 and zinc is always a +2. I'm not going to penalize you for not memorizing that. If you're naming it and the second part, the anion, is just a single atom with a charge, you change the ending to "ide." If it's ending with a polyatomic ion, never change the name. You memorized it for a reason. Let's look at some examples. Calcium and bromine would turn into calcium bromide. Ba3P2 would turn into barium phosphide. CuCl2, now we have to think, because this is a transition metal, we have to include a Roman numeral in our name. Because it bonded with 2 chlorines, each which has a -1 charge, this must be giving up 2 electrons. So it would be copper 2 chloride. How about this one? Nitrogen likes to gain 3. 1 cobalt is satisfying it, so that means that this cobalt must be losing 3 electrons, and it would be cobalt 3 nitride. How about this one? 2 oxygens. Each would like to gain 2. So this needs 4 electrons to be satisfied. Iron is satisfying it just 1. So that means that this iron must have a +4 charge. And that is it